Always the mute mic. Hello, community. Hello, everyone. I hope you are doing well. I hope you had a great break and holidays together with your family and beloved ones. As you know, we did a short break during December to just charge our energies, and consequently, we are back in January for more Cloud Launch and Learn. And today we have a really amazing and special speaker and guest. But before I hand over, I just want to quickly invite you to use the chats. If you have any questions related to the session, you can always share your questions in the chat. We will be answering your questions. Also, feel you are welcome to share with us where are you connecting from, and how was your experience during these holidays. Did you do anything special? Did you study for any certification? um, all this information is relevant to us as well, to help us as well to organize the next and the future sessions to be as useful as possible to you. Okay. Without further ado, I'm going to just bring our speaker.
Okay, welcome everyone. I'm
Hi,
André
Andy.
Mancia. This is my cat. She's called Leola. And as you know, we're going to do a session on machine learning and machines taking over the world. And our only salvation is the cats, because the cats are the only ones that can actually fight the machines, eat all of the cables and actually turn them off. So my cat is here just to make sure that the session will actually go well. Plus, with world domination scenarios, there's always a guy almost without hair trying to, fondle a cat. So this is always normal. So let me just, okay.
So, Andy, how are you doing? All good?
Okay, so let's get started. Okay.
Can you hear me fine, Andy?
All is good. So should I share the screen? Is it already shared?
Yeah, 1 sec, I'm gonna share. So I assume you can see my screen, your screen in this case, sorry.
Okay, I think perfect. Thank you very much. Okay, so
The stage is all yours.
let's
For
give it a try.
everyone, feel free to share your questions in the chat, and we'll be sharing with Andy, and then he can answer them. Okay, thank you very much.
Okay, thank you very much. So let's get started. Before we actually do, let me try one or two things. So first of all, let's go here to Azure. So this is azure.com. We can get started here. Let's go to products, and you have AI machine learning, and we'll go into actual demos, but for now I want to do a very quick demo to see a few things that machine learning can actually do. So we can go to cognitive services, and down here we have speech, and we have speech translation. And the reason I'm doing this first before anything else, you'll get the idea. Let's start with source language. So Ugo is also Portuguese, so we'll start with Portuguese here, and we'll have as target language English. There was no cat target language. If it was, my cat would understand it, but let's try it. So first of all, Hugo, muito obrigado por me convidares a estar aqui nesta sessão. Okay, so I think that this translated correctly. This was live. Anyone can do this. You can just go to the Azure.com website and try this out. This works really well. And this uses something called cognitive services. Cognitive services have things like speech-related things, visual-related things like image processing, image analysis, etc., and a lot more. And you can actually try this out for yourself. However, I was actually speaking in Portuguese, and for anyone who might have a disability, it's always nice to have some subtitles underneath. So if we go to places like here in PowerPoint, there is actually an option that says that we can continue and speak with subtitles underneath, and you can actually translate that into multiple languages if you want to as well. One of the other things that we can actually do is we can take this text, let's copy this text and use a slightly different one. So let's go here for AI machine learning again. I will talk about some of the other products, but we'll focus mostly on Azure machine learning. But let's talk about cognitive services just for the seconds to show you what you can do. And remember, all of this uses machine learning. So, oh, sorry, this one actually. So text to speech. So we can actually do a text to speech option. So give me a second. And we can actually replace this and try United Kingdom English. Oh, let's do a slightly different one. So English, but let's say Australia. I really, really like the Australian accent. So let's say play.
You can replace this text with any text you wish. You can either write in this text box or paste your own.
This was actually the one I wanted to play.
Hugo, thank you so much for inviting me to be here at this session.
Okay, I'm not sure if you could hear this. Hopefully, the screen the screen actually shared the audio as well. Hopefully, this is okay. So all of these things use machine learning, and if you are getting started with machine learning, the first thing you're gonna think about is, all of this is very complicated. What do I do? How can I use this? This is too advanced for me. The answer is actually no. It's very simple. Anyone can do it, okay? And to get started, all you have to do is to use machine learning. No one expects you to program algorithms for machine learning. That's crazy, okay? That's a lot of work. That's too much advanced work. But you can actually play around with the thing that someone else has done for you. So a lot of algorithms are already created. They are very easy to use, and you can just use them. Okay, so during this session, we'll actually see how machine learning works, and then try to do a few actual practical demos so that you can actually use it. So let's see what happens. Let's give it a try. So I have my subtitles here. I think we can leave them, so this is okay. Sometimes they fail, but this is all right as well. So we'll get started. And again, this is my cat. This is Leo. That means lioness in English. And yeah, this is me. My name is André Melancia. I do a lot of sessions on crazy topics, as much as I can do. The crazier, the better. That just reflects the craziness of me. And this session is all about machine learning. So once again, thank you very much for having me here. We'll try to have some fun. This is going to be the first session of the year, not just for Cloud Lunch and Learn, but also for me as well. First session of the year. Okay, and last time I actually presented this was in the beginning of December, and I left this, and this was very applicable on that day, and I just left it here because I felt that this was also important to mention, that this is actually something that I follow with great interest. Someone who has a disability like hearing impairment, like blindness, or any other kind of disability, can actually benefit from all of these technologies. So we saw speech to text, text to speech, speech translation, etc. A lot of these can actually help someone with disability. We can see that someone who cannot hear, for instance, will actually be able to see the subtitles that I have down here at this moment. Okay, so that's the general idea. We can use technology to help anyone. So if for some reason I have a bad voice like I actually do today, I could actually switch to writing all of the text and speaking the text out loud. I will just replace it with T. Hopefully this will solve the problem. Sorry. Okay. But please bear in mind that all of these machine learning technologies can actually help make the world a bit better for everyone. Okay, let's give it a try. And as Hugo mentioned, if you have any questions, please ask. That's why I'm here. I would love to have your questions anytime. You are free to ask them, and we will try to answer them as much as we can. Okay, so far no questions as far as I can see. Okay, so let's give it a try. So first of all, what is machine learning? Before we actually talk into these algorithms, well, machine learning and artificial intelligence are two things which are not exactly the same. So artificial intelligence is an area of study that actually includes machine learning. Artificial intelligence is the kind of thing that actually takes a lot of different smaller things, and is able to do things like drive a car, or anything intelligent that we see nowadays. And machine learning is actually a subset of artificial intelligence, and it's very, very deterministic, in fact. Okay, I'm not going to use this word like to 100% of the definition. It's like 90 something percent of the definition, but machine learning is actually very deterministic in the results. So if you feed information to a machine learning training, the machine needs to learn somehow. The result in most cases will almost certainly be very close, very much the same, given, I don't know, 1 or 2% difference between the trainings. If you train them twice, the result will be very similar. But how do we do that? Well, we'll see that in a bit. But how does this actually work? Well, it's actually very simple. You take data that you have. Let's say it's a simple table. Let's say you are someone who has an information system. Let's say it's a bank, for instance, and you are processing bank loans. You want to figure out if you are allowed to give someone a bank loan, let's say to buy a house or a car or something like that. In that case, you have a history of bank loans in the last 20 years or something, and that history will tell you if these people actually paid for the bank loan or not in the end. So if they were correct in paying all of the installments of the bank loan, or at some point in time they forgot to pay, which happens. Okay, and let's say that the result is a yes or a no. So yes, these are nice people that did the right thing, or no, they forgot to pay. Okay, and when I mean forgot, we know it's not just forget. This, I can actually use that information of a yes or a no, which is very simple. This is the simplest way we can do it, and actually try to calculate if a new person, based on similar information to the old people that are there, if the new person will actually be able to pay the bank loan or not. Okay, so in this case, what will I do? Well, I'm going to do the training with, I don't know, thousands of people, the information from them, and then just try to figure out if the result is correct or not. Acquire all of the information, and then figure out if the result is correct or not with the information that I get for the new person. Okay, so the first part, the training part, it's literally called training. So the machine learning trains based on some historical data, and then you have something which actually has a lot of names. You can call them scoring, you can call them prediction, you can call them inferencing. So there's actually a lot of names for this. The same way you have, let's say you have a table and you have multiple names for columns. You can call them columns, you can call them fields, you can call them, sometimes if this is BI, you can call them, I don't know, dimensions and metrics and things like that. In this case, this is exactly the same thing. There's a lot of different names for the exact same thing. Okay, so we have the training and we have the prediction part, or the scoring part, if you prefer. And those parts actually require something called an algorithm. And the algorithm is actually common in both of these. These are not necessarily the same algorithm, but this is the someone who creates one should probably create the two algorithms as just one. So we have an algorithm for the training part and a same logic algorithm for the scoring part, or for the prediction part. Okay, so let's say I have something as simple as predicting that yes or no situation. This is actually called a two-class algorithm, and because yes and no are two classes, yes and no. So in this case, I have a two-class algorithm to do the training, and then I do the scoring with the same algorithm, or it might not be the exact same code, but in the end, we call it the same algorithm. Okay, so how difficult is this to do? Well, there's a lot of ways to do it. I'll try to show you. The way to do this with codes is usually very simple. The algorithm is usually a library, and to actually call it, you run one line of code. Okay, seems simple. And to do the prediction, you run one line of code. So what's all of the crazy code that you have before and after? Well, you have the preparation of data. Okay, so that preparation of data requires you to, I don't know, fix any mistakes you have in the data before you feed it to the actual training. But we'll get into that in a second. So types of algorithms. What kind of algorithms do we have? Well, we actually have two types. Okay, we have the supervised algorithms and the unsupervised ones. The supervised algorithms are the ones that I just mentioned in the example. So you have, let's say, a list. This can be a table. So remember that we can actually feed machine learning with tables of data, and well, these are not exactly tables when they are fed. These are called data sets, but think of it as a table if you prefer. But you can also feed it things like images or something else. Okay, so these can be non-tabular data as well. Okay, so let's assume it's actually tabular data for most of the examples we're going to get. It's the easiest way. And one of the things that we're going to try is that the supervised one will have the initial data, which is all of the inputs that people gave it, and the actual results. Okay, so the input data is usually called X, let's say X1, X2, X3. So the field name can usually be considered X, which is the starting point, although you just give it the normal name, but the result sometimes is called a Y, so the letter Y. And Y, because we usually have a graph, X is in the bottom and Y is vertically, right? And the Y is the result, X is the input. So easy as that. Usually you have one result, but you might have multiple results if you want to. Okay, and these are easy. Trust me, it's not complicated. What would be the result in that bank loan? So the inputs would be, the age of the person, or at least the birth date. It would be something like how much do they make per month or per year? If they have kids, if they are married, what kind of job do they have? Life expectancy, all of that stuff, and the result would be a yes or a no in this case. So very, very simple. So you do all of the training supervised. That means when the algorithm is learning, they already know the results. Okay, so a few examples here are classification. This is the example that I mentioned. It's actually a two-class classification because there's two options, yes or no. If we were trying out maybe with everyone who's watching, we might try nationalities. Let's say, actually this is not very good because Hugo's also Portuguese, but he's technically not in Portugal, so it might count as two nationalities, but then someone else and someone else and someone else might have different nationalities. So if we are creating an algorithm to find the nationality of the person, or the country they are physically in at this moment, for instance, we might have a multi-class classification. So it can be a 3-class, 4-class, 5-class, or without numbers. But the most typical one is actually 2-class because it's a yes or a no, and it has a lot of applications like the one that I just mentioned. We also have regression. And what is the regression? Well, regression is when you have like points in a map, in a graph. Right? So it can be as simple as a temperature or something like that. So those two are very easy to predict because the result's already there. But what about unsupervised? Well, that's very difficult. I have no idea what to expect. Okay, so let's assume what we can do with unsupervised. So unsupervised would be something like taking an image and trying to predict if there are people in the image, or taking a background of the image, actually like the one you see here in the back. So this is actually being done by the streaming service. However, you can do it yourself. How easy is it to do it yourself? Well, I'll actually show you. So we can actually start, and I'm not going to use my photo. I'm going to use a much nicer one. Okay. Oh, sorry. So I actually have a Python file here. So first of all, let me show you the image that I have here. So more, actually just image. So I'm just first of all going to show you the image. So this is just a nice dog. That's a carpet somewhere, and there's some other carpet parts. So this is a very nice dog, and we're going to try to remove the background. So what I'm actually going to do is I'm going to do more image .py so that we can see, and we have from and this is the remove backgrounds library. So internally, it will use machine learning. We just don't know, okay? But it will. It's nice for us, okay? And we import a few things. We import images, etc. And then we have the input path, which is going to be that image, and the output path is going to be the py output.png. I've actually run this already. It takes 1 or 2 minutes, so we're not going to wait for it, but I've actually run it. It's here if you want to know. So Python, I actually ran these exact commands just before, and the result would be this. Actually, both of these should be the same. One of them was run before. So if I run pyoutput.png, I actually have the exact same dog. It rotated, no idea why, to be honest. I didn't actually investigate why it rotated. Some images do rotate automatically for a number of reasons, but let's ignore that simple part. But they do remove the backgrounds of the dog, okay? So this is something you can actually try yourself. So you have the code here. This will be recorded, so you can just, write down this code. It's simple enough, and you can try it out. The magic here is this library that you can just import in Python, so not as difficult as that. You can always do you can always install Python on your computer and run pip, which is Python installer, to install some of these libraries if they are needed. Okay, so this is a simple demo just to see how we can use it. And remember, unsupervised training requires you to have images which you have no expectation about. So I'm not going to feed an image to say, here's a dog, and then explain to the machine learning, okay, this is how you remove the background. No one's actually going to do that, okay? The machine learning will understand that there are certain types of images with certain consistencies automatically that they will figure out how to clear out that kind of thing. So I will actually go through each of these individually, which is easier. Before we actually go and explore some of these algorithms, let's talk about the cow in the room. And I don't actually mean this one, but let's talk about this one first. So when you do machine learning and you try to detect objects, and yes, you can do this kind of thing with cognitive services. So Azure Cognitive Services, that would be a job for a different session. All you would have to do is to call some REST API and say, here's the image, give me the results, like the coordinates back. Okay, but this went terribly wrong. Why? Because the algorithm assumed that there might be something in front of the cow. They just didn't assume that the cow would be as big as 5 meters, like you see here. Okay, so any kids that's 2 or 3 years old might actually look at this and say, oh, the cow is very big. And yes, kids are very innocent, and algorithms are innocent as well, and this happens exactly the same way. Okay, so in this case, you would have to make a restraint to the algorithm to say, look, if you are going to detect cows, make sure that the cows have a maximum height of, 2 meters, and a maximum length of, 2.5 meters. I don't know what's the current rating for a cow, but there's has to be a limit. So here, obviously, we assume that there's going to be 2 cows, right, or at least 2, maybe more. Okay, so this is the idea. So you can actually program this, but in some cases you have to program constraints. Now let's have a look at the actual cow in the room, and this is to talk about OpenAI and Chat GTP. Okay, and yes, this is the cow in the room, and everyone is talking about it. And how does this work? Well, the reality is that there is actually a huge algorithm, which is a GPT-2 or GTP 3, in fact, which actually learned from a lot of data, and this is data all over the internet, etc. And it started to, try to give responses. So the actual speaking that you see here is not necessarily part of the algorithm. So you have the learning part, and then you have, let's call it, the interface part. So these are actually 2 distinct things. So reading from the let's call it the knowledge base, it's slightly different than forming the sentences. Okay, so if I ask questions, are you Skynet, etc., etc., so we obviously see a lot of running jokes. This was actually the first service that in less than, a week or something like that, actually raised up to 1,000 million users, and this was very big. It just Facebook took almost a year, like 8-9 months, to actually get 1,000 million users or something. So it's actually 1 million users, in fact. So this is forget about the numbers, it's just big, okay, compared to everyone else. But if you say something, what's important questions for us? What's the meaning of life? Now, this is difficult. Even for us humans, this is difficult. So we ask the computer, the AI, if they can come up with an answer. This is taking a bit longer because we get all of those messages saying, "Oh, our services are full because everyone is using them, etc." But here's the result. The result, whatever it is, it's not going to give us any actual answers in this case. But it actually means that a lot of people talked about this. So I registered that a lot of people talked about this. I also registered that a lot of people talked about something else. Okay. So this is actually a knowledge base. It gives you information. Is it always correct? Well, I'm not going to try it here because the last time I tried it was maybe a week, 2 weeks ago, and they have had an update here for January 9 here. So probably I'm not going to get the same answers. But if you ask things like, is number 3 a prime or some other number a prime, etc. And sometimes they say yes, or is a number divisible by 3? I actually put something like that on Facebook when I tried it, and they say yes, 100 is divisible by 3, and I'm like, no, it's not. Okay, and they say yes, it is divisible by 3, but the result is a decimal result. That's not what we meant when we say divisible by 3 in mathematics, right? We expect an integer result. So in terms of computer, the computer is like a small kid. Can you divide 100 by 3? Yes. Do you actually get a result that makes sense for a simple human? Actually, no. Okay, so that is the actual problem. So this will change a bit. This will be integrated into a lot of products. Microsoft actually mentioned that they will integrate this into Bing. We know that Google is actually quite good with searching, etc., compared to Bing and everyone else. But this might be a deal breaker and actually help people much better than just a simple search engine. We'll see. Microsoft just this week actually mentioned that they will be using this in all of their products. Good luck with that, because it's actually not that easy to implement this, because the problem is actually not using it. Using it is very easy. So using it, you can actually go and look at the, actually it's not here, it's somewhere else, not in the chat part, but in the openai.com part. So you can actually go there and see the documentation, use APIs, and APIs, you send a message like one of these, and you get a message back, which is the results in terms of text. Very easy REST API. If you want to integrate that in products, that's just very easy. If you want to actually train based on, I don't know, Microsoft products or your own products, that's not an easy part, okay? So we'll see what the future holds. I'm not really sure what's going to happen with OpenAI in terms of you being able to use it for your own things, not just generic searching. So far, it's very trending, but we'll see the actual pure practical application, and not pure, but practical application of this. You also have image stuff. So if you go to labs.openai.com, you can actually create your own image. You have to log in, and you have a limit per month. But if you say something like a cat's looking at a full moon. So if you say something like generates, the actual thing will try to generate images based on your request. These were the previous images that I generated, so they are very small here. Sorry about that. But you can see that these look quite good. So these are based on some other images. And here, well, actually, these are nice. So this cat is very, nice enough, and this is the moon, etc. So this was generated on the spot. Okay, so it might be similar to some other images, because people do feed it images and they will try to learn from all of them and generate more. So very fun to do, and the technology is actually groundbreaking. In fact, this is not something that's obvious with just normal machine learning. So this is actually, if you use the APIs for this, this will be a nice application to generate, drawings and things. So that's easy. Okay, so one last thing before I go into a few more slides. So if I go to azure.com here, I wanted to mention that most of the things that we've seen we can actually do with Python and without Azure, but I'm actually going to use Azure, so you can go for the free account here, this green one here, or try Azure for free here. So either one, it's the same. But if you are a student, so if you go for students here in the texts, free/students, you can actually get free credits for a whole year. It's $100. It's not much, but you can use things like cognitive services and all. And these will be, most of the cognitive services are actually free, so you can try them out. Okay, so there is no reason why you shouldn't have access to Azure. You can actually get free accounts if you want to, with students access or without it. Okay, so let's try out a few more things. So regression, I mentioned this briefly. Okay, and this is an algorithm that is actually very simple to explain, probably the simplest one to explain. And when you actually get started, you start with all of the dots. So let's say you have something down here, and this can be, I don't know, any of these, like economics, weather, etc. If you consider things like what's the fluctuation of the pounds and the dollar compared to euro, you're going to get a crazy line, because it doesn't depend on something predictable. It depends on humans, which are extremely irrational. So to actually do it for economics, you can do it for macroeconomics, so the big picture of things. You cannot do it for individual days and for things like the stock market. Good luck with that. People have tried. People have spent a lot of money trying to use machine learning for stock markets and trying to make more money. They just lost money. Okay, so don't try it. Trust me, it's a trap. This is probably the simplest algorithm to try. So let's say that all of these dots correspond to something down here. Let's say that this is, one of the examples I usually mention, and here in Portugal, this is very easy. So let's assume that this is the days of the year. So from left to right, let's say, a simple thing. And this would be January, so very cold. And this would be maybe August. At some point in time, it goes down, of course. But keep it simple. And then we can actually put all of the dots here of the temperature that happened in the last 10 years, 20 years, etc. And at some point in time, you can actually draw a line, a straight line or curved line, depends on what you want, to tell you what kind of temperature you're going to expect in January. So January, you can expect it to be cold. In August, you can expect it to be very hot, up to 40 degrees, something like that. That's expected to be hot. So you don't expect to have negative temperatures in August, okay? So for instance, if you are planning, I don't know, a wedding with food, etc., outdoors, you're probably going to choose August over January. Why? Because you as a human, you have that mentally in your heads, okay? But you can also do that with machine learning. Sometimes it's not as predictable. And other things like biology, you can predict growth of biology and things like that, sometimes with linear things, not necessarily with continuous regression things. Most times they will not be linear. They will be either exponential or logarithmic or something like that, but they will exist and you can try it out. So let's take an example. Let's say it's 70. So 70, you want to predict what kind of value you might expect from 70. And sometimes you had values that could be down here. Sometimes you had values up there, but the average will be on this line. We expect it to be on this line. So 70, and you go here and you get the result of about 60. Okay, so that's applying a formula. So what's the formula? The formula is very simple. You learned it in high school, which is a number here, which is the point of the y axis, which in this case is like 25 round numbers, and you multiply it. So a plus, which this would be that a plus bx. So x would be the 70 and b would be the inclination of this curve. So a and b are your values, and these are called a model. Okay, and model is all of the values that you need to acquire and learn, let's call it like that, and keep, let's say, in a file, so that you can actually do the next prediction. So if you have a and b, you can apply that formula and get results. This linear regression is literally the only kind of algorithm that I can explain to you as simple as this. That's it. All of the other ones are very complicated. So don't look inside of the model files. These are just crazy numbers, okay? But this one is easy. A plus bx, or the other way around if you prefer, okay? So this one is very simple. You can easily predict the results, okay? So for regression, you might have something like this. So in this case, it would be a curve. Finding a curve here, this would be polynomial because you have formulas like x squared plus x plus a constant number, or x cubed, x to the fourth, etc. So this will be a polynomial formula that will try to find the best curve for this thing. And all you have to do is to add the a times x to the cubed plus b times x squared, etc. So those coefficient numbers are the ones you're trying to find. Okay, and sometimes you use just linear, like we saw before, but sometimes you have a lot of exponents, and polynomial can be very big. In fact, that depends on how you program the hyperparameters in some cases. Okay, so here is actually 3D or maybe 4D, 5D, etc. So in this case, instead of a curve, you actually get a plane, which instead of having just one x, you actually have two x's and then the y. But this is 3 dimensions, could be 4, 5, etc. Okay, so don't go crazy with this. You don't have to know this. You don't have to program this. All you have to do is to get the results into to the machine learning function, to the training function, and that will actually learn everything for you. All you have to do is to get a table. So it's easy enough. Okay. So here, regression. This is the example of how linear regression might not do the trick, but a curved regression, so some other algorithm, might make a bit more sense, but not linear, okay, not a straight line. So sometimes you get better values, sometimes you have worse values. Here, all of the red part is the distance between the prediction line and the actual real results. So that's the error distance, okay? And actually, if you gather the average of this error, normal average, or root mean squared average, which is you square it and then you root it so that it gets a better geometric average, let's call it like that. That's actually one of the metrics that you use for machine learning. So the smaller the error will be, the better it will be for you. Okay, so here, this is another example. Linear is awful here. This one is okay. So this one is the nice one. It's a good fit. But this one, if you train it for hours and hours and hours, you might get this result. So if you can extract this exact result and make it perfect. But as soon as you add one more value, let's say exactly where I have my mouse here, it will work for this line. It actually might work for this line accidentally. But if you put it here on top of this valley, up here, it will make perfect sense here on this line, but it will make no sense on this overfitted line. So you have to be careful. Don't overdo it. Okay, there is a point in which this is doing it very little, this is doing it too much. There is just the right point. It's like when cooking. You don't want to have it raw, you don't want to have it burned, you want it something in the middle. Okay, so data source is your friend, so be careful. The result of this, if you try to do the average of this is the average, okay? Doesn't really help you. The dinosaur tells you a lot of things. The result, the real result of the data is probably a line like this. By the way, I drew the line. I'm not sure if this is true. But there's other examples where the line is just a straight line that looks like you did a huge drawing, but you just simply have points either on top and in the bottom that complement themselves, and suddenly you just have a straight line. So be careful, because the data will tell you things. It will look like something. It might be the wrong way to look at it. Okay, it's important to understand your data, not just do one visual and say, oh, I know what the data is. No, you actually have to understand the business. Okay, so anyway, two-class classification, we talked about this before. Okay, so in this case, you might have a yes or a no. And by the way, yeses and nos can be considered a 0 or a 1. But the result of this two-class classification, for instance, which is two-class classification, is actually called logistic regression. And yes, that word regression is back there. Shouldn't be, right? Because regression is the other thing with a straight line. But this is an algorithm that you can use for this. You can also use decision trees and a few others, but they actually use this name. So please don't confuse it. Logistic regression actually applies to classification. It's not actually the regression group of things, okay? So logistic regression here is trying to figure out a yes or a no based on the example that we talked about before. So you can actually have someone, let's say here, that actually failed the bank loan, although that person would be a yes. Actually, the other way around, failed the bank loan, although they would have all of the conditions, and here they passed the bank loan even though they didn't have enough conditions. Why? Because machine learning is not perfect. You can expect an accuracy or a quality of at least 90%. That would be a good quality, but anything above 95% of quality, accuracy, precision, whatever name you want to call it. There's these words that I just mentioned have different meanings, by the way, but whatever quality definition you use, it's usually not bigger than 95%. For that, you need to exponentially calculate the results. Okay, so that takes a bit more time to actually do that. Okay, so in this case, two-class logistic regression is actually very practical and one of the simplest and most used. But you have others. You have things like decision trees and others. I can show you that in just in a second. Okay. So anyway, by the way, those decision trees can actually be used for different kinds of algorithms. Even 1 second. Okay, even for regression, etc. So it depends. Okay. So anyway. Clustering. What is clustering? So let's say you want to find all of the people here in Portugal, for instance, that drink wine and at the same time they buy diapers. Okay, you might find this to be a very strange comparison, but in reality, you'll find that if you try to match the two, you'll actually get high results. So you might think, oh, I just got a kid, so I have to get completely drunk because the kid will never shut up or something like that. No, that might be a social reason, and it might actually be true. That is actually not the real reason. Although, yes, it is true that this happens. The real reason why people buy wine and diapers, or they buy wine and toilet paper, this is also true. So toilet paper has become famous in the last 3 years. But the reason this is true is that a lot of people do their monthly shopping all at once. So when they buy diapers, they also buy the toilet paper. It's not related to the usage that you use the wine first and then the toilet paper or something else. It's just related to buying the things together. Okay, so this can happen. Okay, so when you take conclusions out of this, remember the algorithm will give you a result that will be like a 3-year-old kid's. Okay, so to put it in a simpler way, I can tell you that a few years ago I asked my niece, why do people get divorced? It's a very simple question, right? And she said, because they got married. And this is astounding, right? Because if you think about it, why do people get divorced? Well, for you and me, we might say, oh, they don't like each other. Oh, something went wrong and they cheated on each other or some other reason, right? But the real reason, and that the other reasons will be, 50% of the time, 60%, etc. The real reason 100% of the time is they get divorced because they got married. It's a state machine. You are born, you get married, and then you get divorced, and then you die. Okay, so it's a sequence. You cannot get divorced without getting married first, and this is 100% of the time. Okay, if you do get married and if you do get divorced and then get married again, that's just your problem. Okay, that's just your insanity. But 100% of the time, this will happen in that sequence. It's a state machine. And obviously, machine learning will understand state machines like a small kids and will understand that's 100% of the time. Okay, that's the real reason. Okay, so anyway, a few examples of clustering. So the clustering we saw here, in this case, the horizontal and vertical are not inputs and outputs. The outputs is actually these clustering, round things. Okay, and you can call it cluster 1, 2, 3, 4, 5, or A, B, C, D, E if you want. Okay, and you can actually get those clusters like this, and you are comparing the values of this one with the values of the vertical one. Okay, and you try to match it, but this can be 2 dimensions. Okay, or and this is all 2 dimensions. Okay, but this can actually be 3-dimensional ones if you want to. Okay, so very easy to use. Okay, now going back to the 2-dimensional one, just to explain how this works, you draw 3 points randomly here. Okay, and then you try to find all of the values closer to that point. So if you have a dot, let's say you put the dot somewhere very close to this one. So this one here will be closer to this dot. So suddenly it becomes blue. okay? And the other ones are becoming red and green because they are closer to the dots. And then you move the central dots, the centroids, you move them to the average of all of the dots you had, and then you recalculate again, and then you recalculate again. And the centroids will move a bit until they are stable. When they are stable, you have clusters, okay? So this algorithm is actually not new. It's older than me. It's from the 70s, okay? And so far, it hasn't changed much apart from one or two optimizations. The concept is still the same, okay? So it's actually very typical for you to relate different things together. Okay, and again, if you do this with code, it's one line of code. Okay, by the way, you can do some of these things graphically if you want to. Okay, now I did mention that you might have some techniques inside the algorithms, and this one is called a decision tree. So basically, a decision tree is very simple. You start with this thing. Oh, is it a mammal? Yes. So let's assume it's my cat. So you have a database of animals. Is it a mammal? Yes. Do people keep it as a pet? Yes. So it's a hamster. Oh no, it isn't. It's a cat. So the computer will ask you, will try to figure out what's the difference between a hamster and a cat. And then you say, well, a hamster, does things, but a cat meows. So you replace hamster with a new question, which is, does it meow? If you go for yes, it's a hamster. If you go for it's a cat. If you go for no, it's a hamster. But then you try again with the dog, go all the way down. Does it meow? No. So it's a hamster. And again, you go again. You have to ask a new question. What's the difference between a hamster and the dog? Okay, so this is how machines learn. This is one of the ways, anyway, that machines actually learn. It's creating these decision trees internally. You might think that this is difficult to do, but even 20 years ago, I created some of these with just a few lines of code, using basic and just simple tables in things like Microsoft Access. You can create this with just, 10, 20 lines of code at most. Okay, and these are easy to create. Okay, anyway, give this one a try. 20q.net will have an example how to use decision trees, but with steroids in a crazy way. So give it a try to figure out how they work internally. Try to hack how they work internally. They do have information about it, but it's actually nice to see how they mix all of these together. Okay, anyway, you also have some techniques called neural networks. Okay, this is for deep learning, etc. And this requires you to have all of these computation nodes here that will actually analyze things the same way our brain does. This is much slower, but at the same time, it's actually much more precise, much more quality into the model that comes out. Okay, now having said that, let's show you some demos, okay? And to do that, I need to quickly explain how things work, okay? So typical workflow for machine learning, we really don't have time today to actually show you this. So let me just show you this as this, okay? But this is, but I will show you where the interface is, and you can drag and drop if you'd like. We simply don't have time to do it today, but I will show you other demos. But this one I will show you now. So how do you do machine learning, let's say graphically, like this, okay? You can do it with code, the exact same thing you can do with lines of code, and not that many. There's examples. I will show you exactly where, okay? But you can actually start with this. So let's say you start with the CSV file. So this file will have, tabular data, and then you fix your data in some way, normalize your data, do something with it, fix it, okay? So clean up anything bad, etc. And then you do the training. So in this case, I actually have two boxes to do the exact same training. So there's a special reason, because this one will actually not do one training. They will do like 20 trainings in one time, okay? But let's say it's only one training. So you choose the algorithm here. And then let's say the other one would be a two-class decision tree, for instance, the one with the bank loan, and then you put a box here to say train model, okay, and then you train the model. So why do you split data? Well, because the data comes in, and you say 70 or 80% of the data will be used for training, so that you can figure out all of the magic of the training, and then what comes out of this variable here will be something, or this line here, but it's actually a variable. If you use Python, for instance, what comes out of this is actually a model. So a model can be a simple file with a lot of data that the machine learned from you, okay? And then you score it, or you predict it if you prefer, okay? And you typically, this part is the testing part here, okay? So to actually do the testing, you take the remaining 20% and you test on the remaining 20%, and then you get a result, let's say 90% accuracy, or you might get Spearmint correlation, or other root mean squared error, which is one of the other ones we've seen. The closest it's to zero, that one would be the best, okay? So in that case, you score the model so that you get a value, okay? One or more values that tell you the quality of the model. Oh, it's very close to zero, so it's a good model because it has less error. Or it's closer to 100%, that means the quality is closer to 100%, the accuracy or something like that. So that could be a good thing. Some of them go down, some of them go up, depends on the metric, okay? You need to figure this out. It's a matter of time. You'll figure this out. It's very easy, okay? And then evaluate is just a nice box to show you the results, etc., okay? But basically, this is how machine learning works. And then you take that model that comes out of this, and then you do the predictions. It's usually one line of code, okay? Or you can use this box that says scoring. You can do it graphically as well, okay? Either one works really well, okay? So let's try it out. And yes, in many cases, people say they use AI and machine learning. They're just using ifs. So clearly wrong. Leaving this here, so I'm not going to focus much on this, but you have a cheat sheet for regression things and for two-class classification. The address is here. It's actually on GitHub. So the address is here. Feel free to have a look when on the video later on. It's ML cheat sheets, aka.ms/ML cheat sheets. It should be updated on a regular basis, but here they will tell you what to expect of the algorithms. Linear regression, fast training linear model. So you grow your data, it grows linearly. Okay, but some of them, like boosted decision tree regression or neural network regression, accurate long training times. That means it grows exponentially with all of your data. It's very big, but it's very. Oh, thank you very much. Thank you very much for adding that into the chat. But anyway, it might be slow, but the quality will be very good. Okay, so two-class classification, two-class decision forests. So decision trees, decision forest. It's all tree-based, right? So the naming is all tree-based. Two-class boosted decision tree, quite a good one. Okay, or neural network if you prefer. But then you have others for analyzing texts. Sentiment analysis and things like that, anomaly detections, image classifications, clustering and recommenders, etc. So you can try out different things. Oh, by the way, I did forget to talk about multi-class, but you also have multi-class as well. Okay, so anyone can do this. Okay, I'm going to leave you a long list, and I'm not even going to focus on this. We saw a bit of cognitive services here, but I'm going to show you machine learning because we are almost running out of time. So I do have to show you machine learning. So you get an Azure account, you go to portal.azure.com, okay, and you start with something like this. Plus sign, you can start with Azure Machine Learning, you can start with Synapse Analytics, you can use Azure Databricks, anything is okay. Machine Learning, okay. So, by the way, you don't even need this. You can just use Python if you want to, okay. So Machine Learning, so you start with Azure Machine Learning here, and then you say create, just use the defaults. So create this with the defaults. So all I have to do is to say some name and then some value. This was already created, by the way. So this was already created. Go all the defaults and then say review create and then actually create it. And the result will be you go to your ML thing. Once it is created, of course. So you start, you have it here. It doesn't look like much, but all you have to do is to press a button, launch Studio. And when you do, you jump into this one, okay? And this one is easy. So we are at home. I don't really care about the home. I care about this. Compute. Let's start with compute. Very easy. You have a compute instance. So basically, you can say new computes, and you create a virtual machine, either based on CPU or GPU. Remember, machine learning likes GPU because of all of the math. Okay, much more expensive, but they do like it. You choose a size. It can be cheap if you want to. Okay, give it a name, etc. Next, advanced settings. You follow up on this, and then you create it. Okay, so I've created a machine here. I can actually start it if you want to. Okay, and we have compute clusters, and these clusters are very similar, but you specify a size. You don't use them directly, but from inside your trainings that you have here in any of these three ways, so via notebooks with codes, AutoML, it's all automatic. I'll show you that in a second, or the designer, which is the graphical thing we just saw in the slides. So either way, you can actually use the clusters to do this. Now, Kubernetes and the attached computes can be used for other things. Kubernetes, for instance, is very typical to use for the prediction part. So you create a web service on a container, and that will predict things for your applications. That's actually the very typical one. Those creations will actually be here on the endpoints. Okay, so let me go to the simplest possible one. So you go here for data. You need to create some data stuff. Okay, so you can actually create it by importing data, or you can create diabetes 2, for instance. This is the example. Type can be a tabular type. Okay, next, and then you go from Azure Open Data Sets. Okay, so these are already created, but you can get them from web files, so a web address, or you can get that from a SQL database, or from a local file or something, or from storage in Azure. But Open Data Sets already has a lot of examples. One of them is the diabetes data set. Easy enough, okay, but there's a lot of others you can try, okay? The biggest difficulty with these data sets is understanding what they really are. There's documentation, okay? So I will explain this one. Let me just go for cancel. Okay, I could create it, but let's go for this one, which I already created. So let's say explore. So I can actually, by the way, I can actually consume it before I do that. So I have, if I want to do code and actually call on it, this is the information I need to put into it. And then I can actually say, oh, give me the data sets and put it into a data frame. So a data frame is basically a data set in memory. It's like an array, not so much an array, but similar to an array that you can just use it in machine learning. This is basically how you call on it. And then pretty much you can just say some other algorithm dot fit. It's usually fit to do the training, parenthesis, that data set. And that line of code will be enough for you to do the training. Okay, as easy as that. Okay, so anyway, let's explore a bit and figure out what's here. And I do apologize for running out of time. I will do this demo as fast as possible. So you know, diabetes, it's an illness, and constant illness. So you have age, gender, not really sure which one is which, body mass index, blood pressure, no idea what the S's stand for, some other medical measurement, and the Y is the result. So this result, you're expected to be between, I think someone told me 90 and 120 for diabetes, but you can get much more or much less, etc. But this is the result. So you can calculate if you are predicted to have diabetes or not based on that. So you get all of the data in, and then you get the Y result out to figure out if you might have diabetes or not. So our inputs are all of the ones except the Y, which is our outputs, okay? So AutoML, this is already here, by the way, but I'll show you the wizard how to do it. That means anyone can do it. You can start right away to actually use machine learning in your applications. So create, and then you can create a new data set. Mine is already here, so I'm not going to create it again. Next, and by the way, to train this, it takes like half an hour. It's already done, so I will show you this done. So I can actually say experiments, probably create a new one, target column. So the output will be the Y column, the one we just saw. And then compute type, you can actually say compute cluster, and I have a compute cluster. That one, so I can use that one. And then you just click on next a few times. There's a lot of configuration that you can fine tune, but basically you click on next a few times and then it runs the training. So the training will be this. It was actually there, but this is the training. So diabetes experiment is the training results. Okay, so you have the result here. And this one, you can actually say, what is AutoML? First of all, AutoML is something that you run multiple times. Instead of just running once, you run it multiple times with different values. In this case, you even run it with different algorithms to figure out the best one. So if you say include child jobs here, you're actually going to see something like 50 or more. Canceled means that they tried, it wasn't very good, so they gave up midway, okay? But some of these, like this one, I've actually highlighted this one so I wouldn't waste time figuring out which one was best, okay? So this one seems to be the best one. Okay, how do I figure this out? Well, I can actually go here and say, oh, sorry, actually not this one, this one. Select all of the ones and actually see here, spearmint correlation and explained variance. So you can actually figure out which one is best in terms of metrics and figure this out. So this one is amicable B here. So this one seems to be the best. It's on top. Sometimes the metric is the other way around, but in this case, this is the one that we want. So this amicable B, you can actually click on this. So what can you do? Well, you can actually download the model. And these are files that you can use on a cell phone. You can use this on an IoT device if you want to. Extremely easy. Okay. So how does this work? You can even see the code that was generated with all of this. So there's a lot that you can see. So both this one and this one will give you code, will give you all of the information related to this. So although this one was done fully automatic, behind this, there's actually Python. If you want to fine tune your own Python, you can go there, figure it out, and do it yourself. Okay, a lot of easy things graphically, but if you want to do it the hard way, you can also do that as well. Okay. Anyway, I can actually deploy it to a web service. This will take a bit of time, so we don't have time for this. But if you deploy to a web service, all you have to do is to say the size of the containers, etc., or the machines if you want to. And this will actually create a REST endpoint in which you connect via HTTPS, and then you send in the information of diabetes, like all of the inputs data, and they will give you the output data. Okay, sadly, this is something we'll not have time to do today, but trust me, it's easy enough. Okay, so anyway, test model, you can actually test a model by trying this out as well. Again, this will take a bit of time. Anyway, one of the things you can do is you can actually take the model, you can actually you can register the model here. So the model will be stored in something called a model registry. So this will be stored here, which is very practical. So you can keep all of the old versions of all of the trainings that you did, all of the models that you did. And let's say you do a new training and the training is not as good, you can still keep the old one. Okay, so these models are like files. You can go here and then download the file if you want to download this as an actual file. The inside of this will be crazy. You cannot read it. It's impossible. It's crazy. Okay, but you can actually download it and use it. And then if you want to, as I mentioned, you can actually deploy it. Here you actually have more options, but you can deploy it to those web services, and those web services will show up here as endpoints. Okay, I don't have an endpoint running, but they will show up there. Okay, for completeness, because we really need to finish, I do apologize for running a bit over time, but we have a few options. One of them is the designer, which shows you things like we saw in the slides. I will randomly select one, so this one. Okay, binary classification, this one will actually show something called the adult census income data set. So this data set is nice. It's also a yes or no kind of thing. Okay, so let me just say preview data. Okay, so this was very similar to that bank loan option that we saw. So if I try to see this, you have age, work class, etc. And towards the end, you have the income class. So they say it's less than 50,000 or more than 50,000. So it's a yes or a no kind of thing. And you can use any algorithm to predict this value if you want to. So all of the other ones are inputs. This is the outputs. Okay, so very easy to use it to predict it. And down here, you can actually see that you clean up things here, and then you do the actual training. So training using this model was actually already here, apparently. So this is not a best example. But if you want to train it, it's very easy to get it from the left side if you want to. Okay, so spoiler alert very quickly. And you have the sample data, adult census. You start here, and then you have a split. I'm not going to use the values much, but you can do split here like this. You can go for this one, and then here you have splits fraction, 80% to the left, for instance. Okay, so now the left part will be 80%, the other part will be 20% here, and then you can actually do train here. Train, give me a second. Train. Give me a second. Where's train? Train model. Give me a second. Train model. Here we go. Okay. So, oh, wait a minute. untrained data sets. So this one is this one. Oh, sorry. This one is this one. And then this one is untrained models. So you can try with the 2-class something. In this case, 2-class boosted decision tree here. So I'm going to put it here. This one should be going here, something like this. And then the result that comes out of this will be your model. You can do the scoring after, etc. But basically, the result that comes out of this will be your model. And then in the end, all you have to do is to, let me get rid of this one. All you have to do is to validate and then submit, start it, etc. You can continue on to this and then do the web service from here as well, graphically as well. So very, very easy to do. Just click on submit, it does things, and then it says deploy, and then you actually it says create web service first or prediction web service first, and then you can click on deploy and it will deploy everything for you automatically, just graphically, very easy to do. Okay, most of the things are done for you automatically. Give it a try, it's worth it. Okay, I actually have longer sessions, like 2-hour sessions and 3-hour sessions on this. If you go to my website, where I actually explain in detail how this is done, clearly in 1 hour this is impossible. Okay, last but not least, just mentioning the notebooks. So there's a lot of notebooks that you can try. You can go for samples. A current version is SDK version 2. So you can start with samples like SDKs of either Python or C# using .NET, of course. But let's try Python. And you can try any of these. So how does these work? Let's try one of these randomly. So as we're getting started, you can go here and say clone. Okay, and then you clone it here to where it says your name. You can clone it. By the way, yes, you can do source control and have this in a repository, much easier. In this example, I don't, but of course you should. So you clone it, and then you go here to files, and then you can play around with the actual things. So I don't have this running. I think I tried to run this. I ran into a problem, a compatibility problem, because this one is actually version 1, but you can actually run things, and these are very easy. So this is just a simple code that says, oh, look, create a compute target to actually create a cluster. So all you have to do is one line of code to create a cluster from scratch. Very, very easy. Actually, you configure it here first, and then the create part is here, but you can use one line if you want to, okay? And you can actually analyze images and things like that by looking at the actual images. This one is very interesting, although yesterday I did try it, it fails. This is version 1, so you need to use an old NumPy library that wasn't the actual value. So there were some issues. I didn't really debug them. It used to work, so last month it worked well. This month I was actually trying this out. There was a bug with the NumPy library, no idea, but hopefully it will either be fixed in a few days, or you can just use the older version of that library. But in any case, you can actually see this one is actually nice. I like this one a lot. Image classification, you take a lot of images of digits, okay, which are handwritten, and then you try to do, these are the labels that a human actually corresponded, but then you can actually predict next time you have a drawing of a number or a letter. In this case, these are only numbers. You can actually get the labels, which are the numbers from 0 to 9, and figure out what's actually written there. Okay, this is how OCR works. Okay, so the MNIST database, go to Wikipedia. MNIST database is actually very famous. 70,000 characters. Obviously 7,000 of each, because there are 10 different characters. But you can try this out by yourself. Okay. First part is actually to do the training. Second part is the deployment into a web service and actually try the prediction yourself. Really easy to do. But you can also try a few others like PyTorch images. So you can use PyTorch. There's a lot of open source libraries like PyTorch, like TensorFlow. Scikit-learn is probably the most interesting one. This one uses Scikit, for instance, this MNIST database uses Scikit-learn, which is probably the most used library in the world. Start with that one, really nice. It's called no idea, Scikit-learn. So it will be, this one is the one you want to start with. The part that says learn helps a lot, okay? But it's not just about learning, it's actually using. Many people use it because they start learning from here, and it's actually very practical. So scikit-learn.org. Try this out first. really easy to try. Okay, and then you go to more difficult ones. Okay, so
Andre,
anyway,
sorry for interrupting. We are just 10 minutes
run out
over,
of time.
and you know what I mean.
We
It's
are
2
running out of
p.m.
time.
People need to go back to work, and
Yes, of course. My apologies. So it's my fault.
I apologize. It's only
Uh,
because we are. That's why we time these sessions 1 hour box, and
My
that's why.
fault. My fault.
No
I was
worries.
getting carried away showing all of this. It's always nice, but it's my fault. Okay. So finishing up. Thank you very much, everyone. Okay. You can actually try these out by yourself. As you can see, some of them you can just use Python. Okay. And if you have any questions, feel free to reach out later on. I'm always happy to help with anything. I'm not sure if there's any question. I don't think so. So feel free
Just
to
some
reach out
comments
later.
from Matt. Matt provided some comments appreciating the session, and
Oh, thank you
of
very much,
course,
Matt.
thank you very much,
Okay.
Andre. Really great session. I apologize the rushing, but
No, no, no.
definitely,
This is this is okay.
our sessions, our lunch sessions is typically time box because of that, because people need to go back to work.
I
Rat
definitely
race.
exceeded my time. So, Ugo, thank you very much for having me here.
Thank
It
you,
was
man.
really nice to be able to show these things and to do the first session of 2023, which is going to be a year where machine learning will be used by everyone, because this will probably be the trend words of this year. Will be something like machine learning or machines taking over the world or something like that. So, Ugo, thank you very much. Thank you everyone for being here, and have fun trying out these things. It will be a different world within 1 year. Okay. Thank you all very
Thank
much.
you. Thank you, Andre. Thank you, Andre. And a quick one before we wrap up. I know it's quite a long session. Just, of course, feel free to contact Andre if you want to explore more and go deep dive in certain topics. Of course, you cannot explain machine learning in 1 hour. It's
I
a
tried.
long, it's a lot of topics. But anyway, I shared a few links in the chats. We are going to have a session next week, which is with another great speaker, Liar, and we are going to learn about billing and infrastructure, and also in the perspective of developers as well. So if you want, sign up with us, and I see you and the team see you next week. Okay. In the meantime, have a great day, have a great week, and stay well and safe. Okay.
Thank you,
Thank you
everyone.
very
See you
much.
next time.
Thank you.